Welcome everyone. In this movie we'll be looking at taking one sample of data from a parametric distribution, which will be a normal distribution, and what we want to do is we want to see, based upon that sample, whether or not the population mean value has changed. So what we're going to be conducting here is a one sample t-test using Excel, and we have two methods. We can just use standard hypothesis testing, or we can use the confidence interval method. So if we go to Excel, then what we have here is we have some sample data, and there's 13 sample points. The hypothesis is that the null hypothesis H0 is that the population mean mu is equal to 2,300. The alternative hypothesis H1 is that the population mean mu is not equal to 2,300. So therefore that tells me, because it's not equal, because you can be less than or greater than, that we have a two-tailed test. Now, this comes from the textbook, and in the textbook we're told that the population distribution is normally distributed, but the population standard deviation sigma is unknown. So because of those two facts, we have to use a one sample t-test. So what we're doing is we're going to compare the sample mean, the mean of those numbers, against what the population mean is believed to be, which is 2,300. Okay, so what we do is we set up this step structure. Step 1, step 2, step 3 is to provide the significance level. So we've decided to test at 5%, which is 0.05. Then step 4 is to extract all the relevant statistics that you need. So you need the population mean, well, that's believed to be 2,300. You want the sample size. Well, the sample size is given by the Excel function count, which is 13. Well, we can see that from there. Okay, we want the sample mean, which is the Excel function average for that set of numbers, C5 to C17. We can then calculate the mean difference between that number and that number to give me minus 25.46. We can then work out the sample standard deviation is from this equation here, or using the stdev.s Excel function, and that comes out to be 352.49. Then we can work out the standard error. The standard error, remember, is just s divided by the square root of n, which comes out to be 97.76. Substitute the numbers in, we get a t value. So substitute the numbers in here to give us the t value, the calculated t value for this sample data compared to the population mean is minus 0.26. Now that's quite a low number. So we know, just because t is quite small, that the null hypothesis will be accepted as being true based upon the sample data collected. And remember, the key is how you collect sample data to make sure it is representative of the population. Okay, now we could take that just from that number there. Now, if we wanted to complete the hypothesis test, then what we'd have to do is say, well, look, we need the p-value, okay, or the critical t-value. So how do we get those? Well, we know the number of degrees of freedom is n-1, so it's G20, which is minus 1 to give me 12. We can calculate the two-tail p-value using the Excel function t.dis.2t, as you can see there, and that comes to be 0.79894, etc. Then all we do then is compare that two-tail p-value with your significance level, which is 5% two-tail, and we can see that that number is bigger than that number, therefore we would accept the null hypothesis. So based upon the sample data being representative of the population mean is still 2,300 based upon that sample data. So that's the p-value method. But what you could do is you could do a t-value method, a critical t-value method. So how do you get the critical t-values? Well, you can see there we've got an upper t critical, which is positive, and a lower t critical, which is negative. Remember your distribution. When you got t, the middle is 0, to the left is negative, to the right is positive, and we can use the Excel function t.inv.2t to give you those numbers. So we got from minus 2.1 to plus 2.1, and you can see that our value lies between that number and that number. So again, we would accept the null hypothesis. You would get the same conclusion no matter whether you use the t against the critical values or the p-value against the significance level. So that's the standard hypothesis testing procedure. Okay, now the other alternative is to construct a confidence interval based upon this for the population mean mu. So what you'd do is you'd say, well, look, what would be the upper value of mu and what would be the lower value of mu? So you construct a confidence interval, as you can see there. So we know we're working at a significance level of 5%, two-tail. The sample size is 13. We know the sample mean. We know the sample standard deviation. We know the standard error. We know what the population mean should be. We know what the population difference should be between the sample mean and the population mean. So we get degrees of freedom is 12. The critical t value now is given by the Excel function t.inv.2t. Okay, so you can now get the confidence interval for the difference is 213. Remember, that's just t times the sample mean minus population mean. And then you get a lower t value, which is minus 238, and an upper t value is 187. Now you can see that our difference, sample mean minus population mean, lies between that number and that number. So you would conclude then that it's not in the extreme zones. So you would conclude that the evidence suggests that you would accept the null hypothesis. You get exactly the same conclusion as you would do in these standard hypothesis testing procedures. But in this case, we're just calculating the confidence interval, and then we're comparing the confidence interval with the difference between the sample mean and the population mean. Please note, I've also included there the calculation of the confidence interval for the difference using the confidence.t function. Okay, so that's it for today. In the next movie, which will be M4 SPSS, we'll solve exactly the same problem using SPSS. So bye.